Hello, creators. We are on video number 4 of momentum and impulse. Remember, we said the momentum is the product of the mass and the velocity of an object. And then we said the momentum is a vector quantity. It has the magnitude and the direction. The SI units for the momentum is kg meters per second. Then we also did Newton's second law in terms of momentum, which states that the net force is equal to the rate of change in momentum. Now we are on video number 4, that is an impulse. That is the impulse. Impulse is the product of the net force acting on an object and the time the net force acts on an object. Impulse is also a vector quantity. Okay, so it's the product, which means we multiply the net force and the time, then we get the impulse. Now impulse is equal to the net force times, or net, times delta t. That is an impulse. Okay, so the SI units for the net force, the newtons, then the time, seconds. Therefore, the SI units for the impulse will be Newton second. Remember, I said it is a what? A vector quantity. Okay, so if you still remember, we said Newton's second law in terms of momentum, net force is equal to the rate of change in momentum. Now if you can cross multiply here, let's say you multiply by time this side and this side, you multiply by the time, this cancels that, we get the change in momentum. Then in this side we have what? F net times what? Delta t. This is the product of net force and the contact time, which is what? Impulse. This is an impulse. Okay, so in other words, impulse is equal to the change in momentum. Impulse is also equal to the what? Impulse is also equal to the change in momentum. Impulse is also equal to the change in what? In momentum, because this is an impulse, this is a what? The change in momentum. This is a what? An impulse. This is the change in momentum. Impulse is also equal to the change in momentum. All right, let's go to example number 1. This is the mass of the ball hits a wall at 20 meters per second and bounces back, making a contact with the wall for 0.1 seconds. The momentum of the ball changes by 15 kg meters per second. Ignore the effect of gravity and air resistance. Calculate the magnitude and the direction of the impulse that the wall exert on the ball. So we have the wall here, we have the ball which is going towards the wall. Then the wall exerts an impulse. Then the ball turns back, changes its momentum. Okay, this is our initial velocity. This is our final velocity, right? Okay, now let's look at the SI units. So we have the mass in grams, wrong. The velocity in meters per second, correct. The time is correct. It is in seconds, so it's perfect for substitution. Then we have the change in momentum. They said the momentum of the ball changes by, which means this one is the what? The change in momentum. This one is the initial momentum. So what we need to do is to change the mass. So mass will be equal to 500 grams divided by 1000. Then we get 0.5 kgs. This is the correct mass that we are going to use when we substitute. Remember, we said that the impulse is the product of the mass, or is the product of the net force and the time, which is also equal to what? The change in momentum. Meaning that if we have the force and the time, you multiply them, then we get impulse. If we have the change in momentum, that is an impulse. If we have the mass, the velocity initial and the final velocity, we will get the impulse. So you can use this side or this side to calculate the impulse. Now we have the change in momentum. This change in momentum causes the object to move back, which means the direction for this one is backward or is away from the wall, which means we are going to say -15. That is our impulse is -15. Okay, this is the impulse. -15. The SI units for force are newtons. Then we have time in what? In second. This is an impulse, which is the same as 15 Newton second away from the what? From the wall. That is number one. Let's go to question number 2. Question number 2 says calculate. Number 2, calculate the magnitude of the average force. All right. So in this case, we are going to use the same formula. That is number 2, F net times delta T, which is equal to the change in momentum. All right. The magnitude of the average force that is exerted on the ball by what? By the wall, which means we are looking for the force away from the wall. Okay, so which means we are going to use the change in momentum away, or the impulse away from the what? From the wall. So the force is what we are looking for. The time is 0.1 seconds, which is equal to the change in momentum for away exerted by the wall toward to the ball is -15. Then we divide by 0.1. Then we get the net force, which is equal to 15 divided by 0.1, which is equal to -150 newtons. So it is 150 newtons since it is negative away from the wall. Away is a force that is exerted by the wall to the ball. Force exerted by the wall to the what? To the ball. right? Then let's go to number 3. Number 3 says calculate the velocity with which the ball rebounds. Okay, rebounds. So we are looking for the final velocity now. That is number 3. So we have this formula. That is F net times delta t is equal to change in momentum. So we can also use this one because we do have the change in momentum. Change in momentum is equal to momentum final minus momentum initial. So the change in momentum is also equal to mvf minus mvi. So the change in momentum is negative 15, which is equal to the mass is 0,5 times final velocity minus the mass is 0,5 times the initial velocity. The initial velocity is 20 meters per second. 20 meters per second. So we have 15, negative 15, then 0,5 VF, then minus 0,5 times 20 is 10. Then you transpose 10, you have minus 15 plus 10, which is equal to 0,5 VF. Then we divide by 0,5. We divide by 0,5. So minus 15 plus 10 is 5. So we have minus 15 plus 10 is minus 5. We have minus 5. We have minus 5 divided by 0,5, which is equal to VF. Then 0,5 divided by 0, or 5 divided by 0,5, it's minus 10. Minus 10, which is the final velocity. Therefore, the final velocity is equal to 10 meters per second away from the wall. So example 1 is done. Let's go to example number 2. This is example number 2. A bullet with a mass. So this is the mass of the bullet, which is 15 grams, moves at 200 meters per second. 200 meters per second, passing through a wooden panel. It leaves the panel at 150 meters per second after the time of 0,025 seconds. Let's look at the SI units. So the mass is wrong. It's supposed to be in kgs, which means we need to convert it. The speed, initial velocity is correct. The final velocity is correct. Meters per second. The time is in second. Correct. So let's change the mass. M is equal to 15 grams. Then we divide by 100 or 1000. Then we get 0,015 kgs. Right? Then the question says calculate the force that is exerted or that is applied to the bullet in order to reduce its velocity. Remember the formula for impulse, F net times delta t is equal to change in momentum. Okay, then we are looking for the force. The bullet with a mass 15 grams moves at 200 meters per second, passing through, which means the direction for initial velocity and final velocity is the same, so everything will be positive there, right? So F net times delta t is equal to the change in momentum is mvf minus mvi. Now let's substitute. We are looking for the force F net times the time is 0,00025, which is equal to the mass is 0,015 times the final velocity is 150, then the initial velocity is 200, so we have 0,015 times 200. Then we press calculator here. So we get negative 0,75. Then we divide by 0,0025 both sides. 0,0025. 0,0025. So F net is equal to, divide by 0,0025, divide by 0,0025. So the answer is negative 300 newtons, which is equal to 300 newtons backwards. That is example number 2. Thank you for watching the video. Please make sure that you subscribe and you like the video. Don't forget to comment. Thank you. Let's go to the next video, that is the conservation of linear momentum. Conservation of the linear momentum.